Hello, this is the luckiest maths teacher in the world, and by the end of this video you'll be able to sketch any parabola that I give you. Now, we've already seen the graph of y equals x squared, and if we don't know how to get that, we can get it with the table of values. But remember, y equals x squared looks like this. So this is the graph of y equals x squared, and it's the x squared, because the x is squared, that makes it non-linear. So this y equals x squared is a quadratic equation, and its graph is a parabola. And all parabolas have this same shape. They just might have a different orientation. So they look like that or like that. So there's two things that make this really different from a linear function. So one of them is you can see that the parabola here is going down, and then it reaches a point here where it sort of turns around and then it goes up. That also means that the parabola has some symmetry, and the reason for all of this is because when you square a negative number, you get the same answer as if you square its opposite. So when you square -1 and get 1, that's the same as when you square +1. They give you the same answer. So each time you have a given y value like 1, a positive y value here, there are two corresponding x values. The other thing that makes it different from a linear function is that a linear function has a constant gradient. So if I wanted to draw a line, remember it goes through 2 points and the gradient is the rise over the run. But for a line, the gradient is the same at each point. So each time to get a new point, I'm going across 2 and up 2. And then if I join all of these points, it becomes a line, right? So it has a constant gradient, but the gradient is different for a parabola. So for example, we see that to go from this point here to this point, the turning point, I go down 2 and across 2, right? So the gradient there is kind of like 1. But let's say I want to go from this point here to this point here. I go across 2 units, or I'm really going across 1, but I go up 1, 2, 3, 4, 5, 6 squares. So the gradient is different in different parts of this curve, and that's what makes it a curve instead of a line. Now, what we've already learned is that if we know the graph of y equals x squared, we can graph some other ones pretty easily. So the graph of y equals x squared plus 2 is just the graph of y equals x squared shifted up 2. So that would have a turning point here. I just moved the turning point up 2, and then it has the same shape. So it is going to look something like this. Okay, sorry, I can't use a ruler or anything on this. So this is the graph there, and that is very, very easy to find out. We're just shifting it up or down. But if I change this value at the end, the thing I'm adding to a negative, so like y equals x squared minus 3, then that doesn't shift it up, it shifts it down. So y equals x squared minus 3 looks like this. So what I've done is I've taken the turning point, which was at 0, 0, and I've shifted it down, okay? What we also looked at is if we have a number in front of x that can dilate the graph. So I'm just going to quickly show you that. So I'm going to get rid of what is on the screen here. So please pause and copy down if you want to have this stuff in your book. So remember, if you have a number in front of x squared, that dilates it. Higher numbers make it thinner. So y equals 2x squared would be a lot thinner than y equals x squared, but that doesn't change the turning point. So I might have something like this. Again, sorry for my rough drawings. That could be y equals 2x squared. Having a number in front of x squared like that doesn't change the turning point. If I do say y equals a half x squared, that makes the graph fatter because it takes longer for the graph to rise. So y equals a half x squared might look something like this. Okay. So that just dilates it. So what I'm saying here is because I know the graph of y equals x squared, I can draw some parabolas very easily. So remember though, if the number in front of x squared is negative, then that reflects the graph of y equals x squared. Okay, so now I'll draw y equals minus x squared. It inverts or turns the parabola upside down but doesn't change the turning point. So it has the exact same shape as y equals x squared. It's not supposed to be fatter or thinner, it's just made it turn upside down. So although the turning point didn't change for any of these, the turning point of y equals minus x squared here, sorry, I'll do another colour, here, is still 0, 0. That's the point at which the parabola turns around. But instead of being the minimum value that y can take, it's now the maximum. So this one has a maximum turning point, whereas all these ones up here, they all had a minimum turning point. So when we say minimum or maximum, we're talking about y values. So in all of these ones up here, y equals x squared, y equals 2x squared, y equals half x squared, you can see that there were no points down here. So the minimum value y can take is 0, and that makes sense. For y equals x squared, I mean, you can't square a number and get an answer less than 0. So 0 is the minimum value y can take. So it's a minimum turning point, but for this one down here, 0 is the maximum. You can't have minus x squared equaling something greater than 0. Okay, I'll show you the last type of translation now. So I know from previous example that if I say have y equals x squared plus 3, I know that that moves y equals x squared up 3. But if I put the 3 as part of the squared, it shifts it left or right. So if I have y equals x plus 3, so now the 3 is part of what's being squared, it shifts it left and right. But the thing is, it sort of goes in the opposite direction than you would expect. So for y equals x plus 3, it actually shifts it left by 3 units. Okay, so if this thing here is positive, it goes left. If it's negative, it goes right. So for y equals x plus 3 squared, I take the red curve you can see there, y equals x squared, and I just move it over here. So again, when I say shift the curve, think of me as shifting the turning point. I'm not changing the shape of it, however. So for y equals x plus 3 squared, its turning point is now at minus 3, 0. I've just shifted it left, I haven't shifted it upwards. And it will have the same shape as y equals x squared. Okay, again, you can draw yours a lot neater than I can on here. Okay, so that would be y equals x plus 3 squared. So if you have a negative number that's being squared in here, then it moves it to the right, just like I said. So let's graph y equals x minus 4 squared. So that, because there is a negative sign there, means that it shifts right, and because it's a 4 that we've put in the brackets with x, then it's 4 to the right. So the turning point would now be here. I've just shifted it 4 to the right, and I haven't changed the shape. It goes on like this, okay? So these are simple, all of these that I've shown you, shifting left or right, or dilating, or shifting up and down. These are all pretty easy to do because we know the graph of y equals x squared. But unfortunately, parabolas get a bit more complicated than that. Sometimes you just can't look at the equation and say, okay, this has been shifted left, right, whatever. And so we need another method for that, which I am going to go through now. So we know that a parabola is the graph of a quadratic, and a quadratic is any equation of the form y equals ax squared plus bx plus c, okay? So it's got that x squared term, it also has a linear part as well. So when you are to graph things, there are 4 things I want you to look for, okay? So the first is the orientation of the curve. So what I mean by that is is it going to be a smiley face, or is it going to be a frowny face, okay? And that's really easy to determine. It's just sort of what we looked at before. Remember when we saw y equals minus x squared, it was this shape? So it turns out that it is a frowny face if A, the number in front of x squared is less than 0, and it's a smiley face if A is positive. So try and think of it like that. A positive, smiley face. Positive, smiley face, you get the link. So that's very, very easy to determine. And just as a note, just as I said, remember if A is greater than 0 like this, the turning point, all parabolas have a turning point, will be a minimum. But here, if a is less than 0 and it's inverted, the parabola that is, it will have a maximum turning point, a maximum y value. The second thing I want you to find is a y-intercept. All parabolas have a y-intercept. And to do that, you let x equal 0, okay? Now, you've got to be careful when you're using this. If it's in the form y equals ax squared plus bx plus c, if it's written like that, the y-intercept is just c. So if this one here, this would be the y-intercept, whatever that number is. But even though all quadratic equations can be written in this form, they won't always be. They might be written as x minus 4 times by x plus 1. In that case, you just let x equal 0 and you'll find the y-intercept pretty easily. The third thing I want you to find is the x-intercepts. Now that's why we did all this practice of solving quadratics, because when you are graphing a parabola, the x-intercepts are the x values when y is 0. And so you have to solve a quadratic. Sometimes it'll be easy, sometimes it will be hard. Now there could be 0, 1, or 2 x-intercepts, depending on the actual curve that you had. We looked at a few. So we saw, for example, if you want to go back to earlier in the video, just have a look, you can, but we saw for x squared minus 3 had 2 x-intercepts, x squared plus 2 had no x-intercepts, and x squared, y equals x squared, had 1, okay? But that will become clear to you depending on the number of solutions to your equation. Now, the fourth thing I want you to find is the turning point. Every parabola has a turning point. Like I said, if a is greater than 0, then it'll be a minimum turning point, and if a is less than 0, it'll be a maximum. So, to find the turning point, which is also the same as the axis of symmetry, they occur at the same spot, you use x equals minus b over 2a. So for the axis of symmetry, that is the line x equals minus b on 2a. For the actual point that is the turning point, x equals minus b on 2a gives you the coordinate of x, and you will need to find the y coordinate by substituting in the original equation. All right, let's go ahead and do an example.